In this video, we want to calculate z-scores and random variables that separate the middle percentage of values. In the first problem, we are looking at finding the z-scores that separate the middle 12%. And what you have to make sure that you understand is that in this normal distribution, the values that are at the bottom are your z-scores. And this percentage is your area under the curve. It's your probability. So we refer to them both ways. So that means that we're using a standard normal distribution. What that tells us is that the distribution is normal, it's bell-shaped. Our distribution is symmetric, and standard normal means they have already converted all of these values to z-score. So that tells us that our mean is 0, and our mean always goes in the center, and our standard deviation is 1. So on the right-hand side, we add 1 to each of these values, and we subtract 1 on the other side. Now, 12% of our data is in the middle. So you should already know that since this is symmetric, 50% of our data is to the left of 0, 50% of our data is to the right of 0. So we're looking for 12%. Let's draw that. And how did I know it will be here? Well, I already did the problem. So our area is 12%. This is 12%. And we want to know, what are the z-scores? What are these numbers at the bottom that are associated with that spot? So we, for this video's purpose, are only using the graphing calculator. And in your graphing calculator, under second and vars, which is distributions, we only use two functions. We use normal CDF, and we use that when we want to find the probability. We want to find this percentage. We want to find the area under the curve. We use the second function, inverse norm, when we want to find the numbers at the bottom, our z-scores if we're working with a standard normal distribution, or the random variables if we're working with a regular normal distribution. And the function inverse norm takes 3 arguments, and inverse norm takes your area to the left, your mean, and then your standard deviation. Now, this is what your screen will look like if you have the older operating system. If you have the upgraded operating system, when you go to second and vars, which is distributions, and go down to inverse norm, then it's not supposed to look like that. I turn that on. And we go back to distributions, inverse. There you go. So now, area, you should automatically know that this area means area to the left. Then you type in what your mean is, you type in what your standard deviation is, and then you go down to paste. If you have the most upgraded operating system, which is the TI-84 plus CE, when you go to second and vars and distributions and inverse norm, I know it. You can just put in what tail, where your data is. You can even just come down and say my area is 0.12, mean 0, standard deviation 1, and this area is in the center. I know, modern technology. I know. And then it gives you those z-scores. But since most likely you don't have that, then we need to see how you need to calculate that. So 12% of our data is in the center, and what we know is that this normal distribution represents 100%. It should explain everything that's happening in this particular distribution. So if we take 100%, everything that's under this curve, and subtract the area that's in the center, then that will tell us how much of our area is left. So this side plus this side equals your 88%. But for your inverse norm function, we don't want to know the area on both tails. We just need the area on the left. Therefore, since this distribution is approximately normal, it's symmetric, then what we can do is take this 88% and divide this value by 2. We split it. So 44% of our data is on the left and 44% of our data is on the right. Now, when we go into our inverse norm function, our area, and we always change our percentages to decimals, 0.44, mean 0, standard deviation 1, and we know that because it's a standard normal distribution. The z-score on the left, the negative one, is negative 0.15. Now, we want to know z-scores, so that means we need the value on the other side, and once again, since this distribution is symmetric, it has to be the positive value, 0.15. Now, what if your data hasn't been converted to z-scores? What if it's like this problem? Then we approach it the same way. Our mean is 100, that goes in the center. Our standard deviation is 15, therefore we add 15 on the right. We subtract 15 on the left. We want to separate the middle 80%, so that means we're looking at the majority of the values are here, well, somewhere in here. And we know all that we have is the function inverse norm. We need to find the area that's on the left. Our mean is 100, our standard deviation is 15. Therefore, if 80% of our data is in the center, how much is left on the outsides? 100% is the total amount of area that we have. We subtract 80% to give us 20%. And we don't want the area in both tails, I just want the area on the left. Therefore, we take the remaining area divided by 2 because our distribution is symmetric. So 10% of our data is on the left. We always convert those percentages to decimals. Second in vars takes us to distributions, inverse norm, our area that's on the left, 0.10. Our mean is 100. Our standard deviation is 15. And our IQ score is 80.78. So that will give us the value on the lower side. Here, we need to know what's the value on the upper end, the higher value. Once again, we use symmetry. So the distance between our lower value, our smaller random variable, from the mean is going to be the same distance as it is on the other side. So what we will do is to figure out how far away is this z-score on the left from the mean. We would take 100, and that 100 is our mean. It's not the 100%, minus the 80.78 to give us the distance on the left. And the rounding depends on the problem that you're working with. Sometimes they want you to round to 2 decimal places. Sometimes they want you to round to 0. Here, I selected 2. Most likely when you're talking about IQ scores, the directions will tell you round to the nearest whole number. 19.22. So our distance from the smaller random variable on the left to the mean is 19.22. Since this distribution is symmetric, that means on the other side, we should have 19.22 as well. Therefore, we take the mean and add that distance, 19.22, and that will give us 119.22. Is there another way to do it? Absolutely. Here, this is the maximum value we were looking for. So we know that 80% of the data was in the middle. We found out that 10% of the data was on the left. So how much of your total data is on the left of this particular spot? 90%. So you could go to second in vars, inverse norm. How much of your area is on the left? 90%. Mean 100, standard deviation 15. There's our 119.22. Well, hope this helps. Have a great day.